In this video, I'll be working through the question you can see on the screen here from the summer 2025 Cambridge A-Level Maths paper 3-1. I'm going to try and show you how to do this question and not just the solution. So definitely pause, rewatch certain parts of the video as you need to. If you're looking for a different question from this paper or a different paper entirely, have a look at the description below. You should be able to find a playlist there, or have a look around on my channel. Okay, let's get into the maths. In question 1, we're first asked to sketch a graph of this equation here. Y is equal to the absolute value of 2x minus 3. Now remember, sketch a graph just means a rough drawing. They want probably for a line, they want 2 points, all interesting points, I would say. So we can do this quite quickly. I'm going to go, hopefully if you can do it quite quickly, you can skip ahead, skip to the next question. But I'll try and go slow so you see what I'm thinking at different points. So a rough drawing, we'll just draw an XY axis. How you draw a line, because this is a line, y is equal to 2x minus 3, except it has an absolute value. How you do this is, I want you to ignore the absolute value. I want you to try and sketch this just line first of all. So how do we do it? A couple of different ways. You can put in x equals 0, y equals 0, get the points on the x and y axis. X equals 0, y is equal to minus 3. And that's the y-intercept. So we could have also just got that, because when it's y equals, the y-intercept is there. Next you could put y is equal 0. Rearrange the equation. We get 2x is equal, let me write here, 2x is equal 3, x is equal 3 over 2, or 1.5. So we'll put that in here somewhere. And I'll draw this line in as a dotted line. You'll see why in a moment. The other way, we could have just said the y-intercept is minus 3, put that point in, and the slope is 2. So we have a line going up, roughly like this, and this point would just be every time we move over 1, we go up 2. So over 1, go up 2, over another half, we go up another 1, so that's 1.5. So we could have got that. We got these 2 points like that. Okay, so this is a line. It's not what they asked us to draw. They want the absolute value. Remember what the absolute value tells us. It tells us if anything's bigger than 0, leave it alone. This part of the line is bigger than 0. It's above the 0 point. So let's just leave this alone and we'll fill that in like that. The next thing it tells us is if it's a minus, change it to a positive. So for example here, we got a minus 3. Let's change it up to a positive. We get a plus 3. Like minus 1 turns into a plus 1. Minus 10 turns into a plus 10. Whatever we get the whole line bounces up like this, roughly drawing. So that's a sketch of this drawing. What the examiner wants to see is this number 3 here, and sorry, I never put it in, 1.5 or 3 over 2. And they probably want to see the minus 3 down here. That's the full marks for question 1 part A. If you are finding my videos useful and would like to help the channel out, on top of liking and subscribing, probably the best thing you could do is to tell other people doing the exam about my channel. Maybe you could share this video in a class WhatsApp group. Then if you feel I've really deserved it and you would like to buy me a coffee, you could become a member on YouTube or on Patreon. You should find links to that in the description below. Now for part B, we have an inequality. 3x minus 1 is less than the absolute value of 2x minus 3. This absolute value here is the same as we dealt with in part A. And there's a reason for that. They want you to do this question a certain way. There is 2 ways to do it. I'll sketch out at the end the second way to do it. But I'll do it the way they were trying to help you do it. They made you draw this picture to help you answer this question. So how do you do this? I'm going to treat this as a function on the left and a function on the right. The function on the right we drew here. This is the sketch of this right hand part of this inequality. Let's do the same, let's do a similar sketch for the left hand side. What I mean there is I want to sketch the line y is equal 3x minus 1. That's the left hand side as a function. We can draw it on the same picture over here. The minus 1 gives us a y-intercept of minus 1, so we'll put that in somewhere there. And then we have the 3, it gives us a slope. So we have a much steeper slope than 2, this was a slope 2. So this slope goes straight up like this and it goes down like that. You could get this x-intercept there. That would be, I guess, 1 over 3. Yeah, if we 1 divided by 3 would be this point there. I don't really care. All I want is this rough drawing we already have. Let's look at this question again then. This function is less than this function. When does that happen on the drawing? It's less than here. It's less than everywhere on the left. Everywhere left of this point, that's less than. After that point, it's always bigger than. It's actually, they're separating as they go up here. So the answer to this question is x is less than whatever number x is here. Whatever number these intersect at. So what this question really boils down to is, forget the inequality. You can say 3x minus 1, when does it equal 2x minus 3, or the absolute value of it? That's what you can boil this question down to. And you can even get it better than this. Forget this absolute value. You can say 3x minus 1, when is that equal to minus 2x plus 3? Where did I get this? This is the line that bounces up. This is the minus part of this inequality, which is, we know what we're dealing with because we drew the picture. The picture tells us it's this bounce part. If you solve this equation, 4x, you will get this point, and we can just put it in here as our final answer. So let's do that. Bring the 2x over, we get 5x on the left. Bring the minus 1 over, we get 4 on the right. X is equal to 4 over 5. So this is the x value where these intersect. So we can say the answer is, when is this less than there? Everywhere left of that, which means x is less than 4 over 5. And that's the answer to part B. Okay, I recommend you do it the way I just showed you, using the sketch, but it is possible to do it without the sketch. It's very often they ask this question and they don't ask you to do the sketch first, so lots of students do it. It's not too difficult. I just like having the sketch. We just need to remember how an absolute value works. Absolute value is really two different possibilities, a plus and a minus possibility. So we can split this into two worlds. We can split this into 3x minus 1 is less than 2x minus 3 when this is bigger than 0. And we need to, I've left out a bit of room there. We need to have this as 2x minus 3 is bigger than 0. When that's bigger than 0, we're in this world. And then the other possibility is 3x minus 1 is less than minus 2x plus 3. That's the, if in here was minus. And that would be the case when, as I said, 2x minus 3 is less than 0. Because when this is less than 0, the absolute value kicks in and changes the sign of everything. That's how we get this sign change. So we just solve this, we rearrange it, 2x comes over, we have x on its own, is less than minus 2. But remember the world we're in. We're in the world where 2x minus 3 is bigger than 0. That means x is bigger than 3 over 2. So this doesn't make sense. We're in the world where x is bigger than 3 over 2, and they're telling me x is less than minus 2. So this one just doesn't count. It doesn't make any sense. To do this one, it's just like we did here. We'll get x is less than 4 over 5. And let's check what world we're in. We're in the world where x is less than 3 over 2, which does agree with this. Less than 3 over 2, just in case you're don't believe me, there's 1 and there's 2, 1.5 is here. We're in the world everything left of this, and our answer is talking about a world everything less than there. So this is fine, this world is fine, that is the answer. So it is a lot quicker to do than thinking about the drawing, but I just find students, and even me or any teacher, make a mistake when dealing with inequalities and moving things around. A drawing is much easier to do it. Okay, that's it for question 1. If you have any follow-on questions or you see any mistakes I made, let me know in the comments. Do me a favour, tell me whereabouts in the question you're talking about. It really helps me answer you. Thanks for watching, have a great day.